When encountering differing voltage readings at a variable frequency drive, or VFD, disconnect, several factors could be at play. These factors can range from the sensitivity of the measuring equipment to the configuration of the VFD itself. Let's examine the potential explanations and recommended actions. Firstly, meter sensitivity is crucial. Fluke meters, like any other brand, come in various models with differing levels of accuracy and sensitivity. A less expensive meter might not be capable of detecting subtle voltage fluctuations or harmonics present in the system, leading to a lower reading. A more sophisticated meter, especially one designed for industrial applications, will typically offer higher accuracy and the ability to measure true root mean square, or RMS, voltage, which is essential for non-sinusoidal waveforms often encountered in VFD circuits. Secondly, capacitive coupling can influence voltage readings. High-impedance meters, such as the Greenlee meter mentioned, are more susceptible to capacitive coupling. Capacitive coupling occurs when the meter picks up stray voltages from nearby energized conductors or equipment. This is particularly relevant in environments with high electromagnetic interference, or ME, such as those containing VFD. The stray voltages can add to the actual voltage being measured, resulting in a higher reading. To minimize capacitive coupling, ensure the meter is properly grounded and that the measurement probes are shielded. Thirdly, measurement technique is critical for accurate readings. It's imperative to ensure that the meter probes are making solid contact with the conductors being measured. Poor contact can introduce resistance into the circuit, leading to inaccurate voltage readings. Additionally, verify that the meter is set to the correct voltage range and that the leads are plugged into the appropriate terminals. Using the wrong settings can result in erroneous readings or even damage to the meter. Fourthly, voltage variations can occur due to fluctuations in the power supply or changes in the load being driven by the motor. These variations can be transient and may not be captured by a less sensitive meter. To accurately assess voltage fluctuations, use a meter with a fast sampling rate or a data looker to record voltage readings over time. This will provide a clearer picture of the voltage profile at the disconnect. Now let's delve into the VFD setup and its potential impact on voltage readings and motor performance. Firstly, incorrect motor parameters within the VFD can lead to significant issues. VFD requires specific motor parameters, such as voltage, current, frequency, and horsepower, to operate correctly. If these parameters are not accurately programmed into the VFD, it can result in suboptimal motor performance, overheating, and even premature failure. Always consult the motor nameplate and the VFD manual to ensure that all parameters are correctly configured. Secondly, an improper output voltage from the VFD can damage the motor. The VFD should be configured to provide an output voltage that matches the motor's rated voltage. If the output voltage is too high, it can cause excessive heat in the motor windings, leading to insulation breakdown and eventual motor failure. Conversely, if the output voltage is too low, the motor may not be able to develop sufficient torque to drive the load, resulting in reduced performance and potential stalling. When troubleshooting voltage discrepancies and motor issues, consider these recommendations. Firstly, validate voltage readings with a high-quality voltmeter. Use a voltmeter that is known to be accurate and reliable to verify the voltage readings at the disconnect. If possible, use multiple meters from different manufacturers to compare readings. This will help to identify any potential inaccuracies in the meters being used. Take multiple measurements over a period of time to account for any voltage fluctuations. Secondly, thoroughly inspect the VFD settings. Access the VFD programming interface and carefully review all motor parameters to ensure they match the motor's nameplate data. Pay close attention to the voltage, current, frequency, and horsepower settings. Verify that the VFD is configured for the correct motor type and that all protection features such as overload and overvoltage protection are enabled. Also check the VFD output voltage to ensure it is within the acceptable range for the motor. Thirdly, consider conducting a load study. Monitor the motor's performance under various load conditions. Measure the motor's voltage, current, and power consumption using a power quality analyzer. This will provide valuable insights into the motor's operating characteristics and identify any potential issues. If the motor is overheating, experiencing excessive vibration, or drawing excessive current, it may indicate a problem with the VFD setup or the motor itself. Furthermore, analyze the motor's harmonic content. VFD can generate harmonics, which are unwanted frequencies that can cause problems in electrical systems. Use a harmonic analyzer to measure the harmonic content of the motor's voltage and current. Excessive harmonics can lead to increased energy consumption, overheating of equipment, and interference with other electronic devices. If harmonic levels are high, consider installing harmonic filters to mitigate their effects. Additional factors to consider include the following. First, check the VFD input voltage. Ensure that the input voltage to the VFD is within the specified range. Fluctuations in the input voltage can affect the VFD output voltage and performance. If the input voltage is unstable, consider installing a voltage regulator to stabilize it. Second, verify the VFD grounding. Proper grounding is essential for the safe and reliable operation of VFD. Ensure that the VFD is properly grounded according to the manufacturer's instructions and local electrical codes. A poor ground connection can lead to electrical noise, voltage fluctuations, and potential safety hazards. Third, inspect the motor's insulation resistance. Use a megometer to measure the insulation resistance of the motor windings. Low insulation resistance can indicate insulation damage, which can lead to motor failure. If the insulation resistance is below the recommended level, the motor should be replaced or rewound. Fourth, check the motor's bearings. Motor bearings are subject to wear and tear over time. Inspect the bearings for signs of damage, such as excessive noise, vibration, or heat. Damaged bearings can cause motor failure and should be replaced promptly. Fifth, review the VFD fault history. Most VFD have a built-in fault history that records any errors or alarms that have occurred. Review the fault history to identify any recurring issues that may be contributing to the motor failures. This can provide valuable clues for troubleshooting the problem. Sixth, consider the ambient temperature. High ambient temperatures can affect the performance and lifespan of VFD in motors. Ensure that the VFD and motor are installed in a well-ventilated area with adequate cooling. If the ambient temperature is excessively high, consider installing a cooling system to maintain the equipment within its operating temperature range. Seventh, examine the motor's load. Overloading the motor can cause it to overheat and fail prematurely. Ensure that the motor is properly sized for the load it is driving and that the load is not exceeding the motor's rated capacity. If the motor is consistently overloaded, consider installing a larger motor or reducing the load. Eighth, evaluate the motor's duty cycle. The duty cycle refers to the amount of time the motor is running compared to the amount of time it is idle. Motors that are subjected to frequent starts and stops or long periods of continuous operation are more likely to experience failures. If the motor's duty cycle is excessive, consider adjusting the operating parameters or installing a motor designed for high duty cycles. Ninth, assess the motor's environment. Harsh environments, such as those with high levels of dust, moisture, or corrosive substances, can damage motors and VFD. Ensure that the motor and VFD are protected from these elements. If necessary, install enclosures or filters to provide additional protection. 10th, consult the VFD documentation. The VFD manual contains valuable information about its operation, troubleshooting, and maintenance. Consult the manual for specific guidance on resolving any issues you may be experiencing. 11th, check the motor's wiring connections. Loose or corroded wiring connections can cause voltage drops, overheating, and motor failures. Inspect all wiring connections to ensure they are tight, clean, and properly insulated. 12th, review the VFD control settings. Incorrect control settings can affect the motor's performance and efficiency. Review the VFD control settings such as acceleration and deceleration rates to ensure they are optimized for the application. 13th, assess the motor's insulation type. Different motor insulation types are designed for different operating conditions. Ensure that the motor's insulation type is appropriate for the environment and operating conditions. 14th, evaluate the VFD cooling system. VFD generate heat during operation, and a properly functioning cooling system is essential to prevent overheating. Check the VFD cooling fans and heat sinks to ensure they are clean and functioning properly. 15th, consider the motor's age. Motors have a finite lifespan, and older motors are more likely to experience failures. If the motor is nearing the end of its expected lifespan, consider replacing it with a new motor. By systematically addressing these factors, you can effectively troubleshoot voltage discrepancies and motor issues in VFD-controlled systems. Remember to prioritize safety and consult with qualified professionals when necessary. If you are unable to resolve the issue, consult a qualified electrician. A licensed electrician has the expertise and experience to diagnose and repair electrical problems safely and effectively. They can also provide recommendations for preventing future issues. They can conduct a thorough inspection of the electrical system, including the VFD, motor, and wiring, to identify the root cause of the problem. They can also use specialized test equipment to measure voltage, current, and other electrical parameters. Based on their findings, a qualified electrician can recommend the appropriate repairs or replacements. They can also ensure that all work is performed in accordance with local electrical codes and safety standards. Remember, electrical work can be dangerous, and it is always best to leave it to the professionals.